a new topic. Okay, see in the last to last session, if you remember, we covered data visualization with MATLAB, right? So today we are going to continue from there only, like, but with a new topic that is your Seaborn. Okay, we'll cover data visualization, but with a different library altogether called as Seaborn. Okay, so what is Seaborn class? Like spelling is import Seaborn as SMS. Now, what is Seaborn class? Seaborn is simply what is okay. Seaborn is simply it is a library, okay, which is built on top of your matplotlib, and it is closely integrated with our pandas data structure. That is Seaborn. Okay. Now, second thing, why we are using, there are two reasons why we are using your Seaborn. Okay, in place of matplotlib. So it includes a large number of plots dedicated towards providing better insights. First reason. Okay, second reason is along with myriad colors and palettes. These are the two reasons why we use Seaborn over Matplotlib. Okay, in the Matplotlib, we saw that we can make multiple plots. You can make line plot, your box plot, uh, your bar plot, your histograms, your pie chart, your line plot, okay, random plot. We can make all these plots in case of matplotlib. Okay, but the problem with that is that we cannot include colors, we cannot beautify the graphs. First thing. Second thing, there are many more graphs available which can be used plus which can be used to provide better insights, to showcase our data set in a better manner. Okay, so for this class, what we are going to do? Okay, we're going to work on this C1 library. Okay, and we are going to use a particular data set. So far, we have been using NB data set. Okay, for this particularly, we are going to use another data set called as your Titanic data set. It's import Cbon, import pandas also will do, SPD, import numpy as NP. These three things you will import. Okay. Now class, we need your data set. So we'll write here T is equal to SNS dot SNS dot load underscore dataset. SNS dot load underscore dataset, and then here we will mention the dataset name, Titanic. Okay, so here you can see class, the whole dataset of Titanic has been loaded, 891 rows and 15 columns. 891 rows and 15 columns. Now what happens? See, I have shown you multiple ways, right, to load dataset inside the memory, Python memory. You can use read underscore CSV, read underscore Excel, read underscore SQL. Okay, then you can typecast some dictionary or list. Okay, or you can directly load the data from the internet also. There is one more way. Okay, there is a function called as load underscore dataset. So there are some famous datasets available. Okay, there are some famous datasets available that we can directly download from the internet. Okay, from the server of Seaborn server, we can download from there directly. Okay, Titanic is one of them. One of the datasets. Okay, now if I show you about the Titanic dataset, what it is all about. So you have to understand the Titanic dataset also. You have to understand the Titanic dataset also. Okay, guys. So here I'm sharing a link over chat with all of you. Okay. So in this link, if you go open this link in your system, okay, you will see that inside this link, it is basically explaining about the Titanic dataset. Okay, there is your, okay. Let me okay. If you open this, okay, so you will find there a particular table We'll find a particular table there, class, explaining the whole data set to you. Explaining the whole data set to you. Okay. So in this data set class, you can see there is your survived column. Survived column means the survived column you can see is either 0 or 1 is there. Now all of us know about the Titanic data, Titanic, right? What happened on Titanic ship? Okay, it sank, right? So here in the survived column there is 0 or 1. So 0 means the person didn't survive. 1 means the person survived. The next is your P class column. P class column means your the ticket class. Either the person was traveling in via third class ticket, via second class ticket, or first class ticket. Then there is sex column. In that, male and female is there. Then there is age column. Then there is SIB-SP. What is SIB-SP? It is basically number of siblings or number of spouses. Okay? On board the Titanic. Suppose I was on Titanic and I was traveling with, let's say, two of my siblings. Okay, so here it will show two. Okay, then parts is there. Parts means number of parent or number of children for each C class. This is talking about each and every passenger. Okay, so let's say passenger 1 was traveling with one sibling. See passenger ID 1. See the index column. Passenger ID 1 means the number was the passenger was traveling with single sibling or spouse but zero parent or children. Okay, then there is fare column. Okay, how much the person paid. Then there is embarked column. Embarked column means class from where the person boarded the ship. Okay, from where the person boarded the ship. So there are three possibilities. Okay, either the person boarded the ship from S location or C location or Q location. Okay, your S means plus S means Southampton, Southampton. Okay. Then your C means Cherbourg. Okay, and the Q means Queenstown. Q means Queenstown. So this is the data that we have, class. C, S, and Q. This is the data that we have. Now, next is your class. Class we have already seen. Class in P class is the same thing. Who means either male or female. Okay, there is adult male. True or false, either the person was adult or not. Adult means above 18 years of age or not. Okay, then there is deck. Deck column means basically on which deck the person was. Okay, now class, on a ship now there are multiple decks present. You can, like, all of you must have seen maybe in movies or somewhere. Okay, on a ship there are floors, multiple floors are there on a particular ship. Okay, so what are they? What are they? Basically they are decks. Okay, so on the Titanic ship there was like A, B, C, D, E, F, G. 7 decks, total 7 decks were there on the Titanic ship. Okay, NN value means, class, what is NN? I told you NN means missing data. Wherever NN is present, it means missing data. Okay, embarked town. Okay, it is telling you, see. Okay, alive, no or yes. Okay, alone. Alone means if the person was traveling alone or not, completely alone or not. So here you can see, class, in some of the columns, no, in some of the columns, the data is repetitive. For example, the embarked column and the embarked town, same thing. Okay, then your sex column and who column, same thing. Your P class column and class column, same thing. Okay, so here we can, if we want, we can drop some columns also. We can drop some columns also if we want to. Okay, class. So now we already have the data set. Now on the basis of this data set, we are going to work on multiple graphs. We'll create multiple plots. Okay, first of them is your heat map. First of that is your heat map class. So for the heat map, we will first need a particular thing called as correlation matrix. correlation matrix. Now, what is correlation matrix first? Correlation matrix means that relation between the columns. Okay, relation between individual columns of the data set. For example, if you can see here, okay, that obviously suppose I am traveling from Delhi to Chennai, okay, or maybe I'm traveling from Pune to Chennai. Okay, so obviously the fare will be different, na? The fare will be different in both the cases. Okay, from Pune to Chennai, from Delhi to Chennai, the fare will be different because of the distance covered. Okay, same thing here also. You can see that there is a fare column. Okay, and then there is an embark column. So now there is some relation between the embarked column and the fare column. Why? Because it depends that from where the person is boarding the ship, at how much he will pay. How much he will pay is dependent on from where the person is boarding the ship. First thing, it is also dependent on it is also dependent on the ticket class also. It is a third class ticket or first class ticket or second class ticket. It is dependent on that also. It is dependent on deck also, like on which deck the person is taking the like booking the room. Okay, either on A deck or B deck or C deck. See, A deck is the topmost. Remember, A deck is going to be your topmost. Okay, and your G deck. G means Goa. Okay, G is going to be your lowermost deck. A is your uppermost, G is your lowermost deck. Okay. So we have understood majorly all about the data. What data is representing. Okay. Now we will create a correlation matrix. How? So right here C is equal to. Okay, this is T, right? Then separate T dot call. Here you can see class. This is basically creating a correlation matrix for us. How? See, it is showing us the relation between survived column and the survived column. Obviously, relation between survived and survived is one. Obviously, complete relation between them. Then relation between P class and survived. You can see there is a high relation. 0.33 is good amount. Okay, then age. Okay, age and survived. There is not much relation between them because 0.07. Then number of siblings, number of parents. Fair has a high relation with survived. Okay, adult male, whether the person was adult or not, okay, is basically again having a high relation. Then alone, okay, whether the person was alone or not, it also have a high relation with the survived column. Now class, remember that all the columns that the correlation matrix is going to consider, okay, are basically the numerical columns or the Boolean columns. Here you can see survived, P class, age, all of them are numerical. Survived, P class. Here you can see it is not taking the sex column because why? Because sex column is in string format. Age column it is taking SIP, SP, Parch, fair also taking. Okay. And second thing, it will take Boolean values also. So adult male it is taking and the alone also it is taking. Because true or false, that means Boolean values are present here. Okay, we have created a correlation matrix. Now we are going to create a heat map out of it. How? We'll write here SNS dot heat map. Okay, simply. So now here you can see class, it is creating a correlation matrix for us. It is creating a, see, correlation matrix is stable. Okay, from the correlation matrix, it is creating a heat map for us. Heat map basically means here, it is based on color. Higher the shade, see, higher the shade of white, okay, higher the relation, higher the shade of black, again, higher the relation. You can give some other color map also if you want. Right here, color map. C map is equal to cool warm. Here you can see the color will slightly change now. In the cool warm, it is taking red and blue only. So higher the shade of red, more the correlation. Higher the shade of blue, more the correlation, but in inverse direction. Okay, that means higher the P class, see this means P class C. P class is here 1, 2, 3. Okay, 1 means highest, 1 means upper class, 1 means upper class. But in whenever we talk about numbers, so we all know that 3 is a higher number than 1. Okay, so here you can see there is an inverse relation, right? That higher the number, lower the P class. Lower the class, higher the number. Higher the class, lower the number. Okay, this is what is happening here. Now you can see that in the P class, there is a negative relation. A negative correlation. That means indirect. That means sorry. That means that means inverse relation between these two columns. Okay, so we saw that higher the number, lower the class. That means you can say that higher the number, okay, lower the survivability. Higher the number, lower the survivability. So this will become what class? This means what? Higher the number. See here about think about this. Higher the number, lower is the survivability. Higher the number, lower is the class. That means lower the survivability, lower the ticket class, lower is the survivability. Okay, that means that upper class people, okay, that the upper class people on the ship had higher chances of surviving than the lower class people on the ship. Higher class people had higher chances, upper class people had higher chances of surviving than lower class people, lower class passengers on the ship. Okay, so here you can, so that is why I'm saying it, both of them are, remember, both of them are your important. Your negative correlation also, positive correlation also, you need to focus more on the number. Okay, or here the shade. So all the blue color shades, class, all the blue shades are important for us. Okay, now in the heat map there is an additional argument that we can mention. There is one more argument that we can mention in your heat map. What is that, class? What is that? Okay, let me copy this. Basically here and not equal to true. And not equal to true. So far you can see, class, here it is just showing you the colors. Okay, it is not showing you these numbers also. Okay, so that is why because that is and not is equal to false by default. But when you write and not equal to true, here you can see, class, in this case you can see the numbers also. The difference between them is here it is showing colors only. Here it is showing the numbers also, the value basically. Okay, so here you can see, class, there is a diagonal, right? A red color diagonal is there. Okay, so either we have to focus on the lower half of the diagonal, okay, or the upper half, or basically the left diagonal or the right diagonal. Only one of them you can focus, okay, because it is mirror copy. It is mirror copy in both the areas. So you can see that there is a relation between alone and survived, a relation of 0.2, relation between adult male and survived, relation between fair and P class. See, higher the class, okay, that means upper class people paid more money. Upper class people, you can see the negative relation is there, minus 0.55 between fair and P class. Okay, so that means upper class people paid more money. Okay, so we saw that P class has an effect on the fair column. Okay, and similarly, P class has an effect on the survived column as well. You can see P class and survived 0.34. Okay, that means fear is going to affect the survivability of a person directly. Okay, then there is a relation between SIB, and alone. Okay, similarly, Parch and alone also, because negative relation again. That means that means obviously if the person is alone, there are lower chances, okay, that the person is traveling with siblings or parents. Obviously, because that is why that person is alone. Okay. So this, okay, then there is a relation between your parch and adult male. See, relation between parch and adult male. Relation of 0.35. Negative relation of 0.35. That means class. What is the meaning of this? That more the age of a male, more the age of a person, more the age of the passenger of the on the ship. Okay, okay. So less parents and less siblings the person is traveling with. If the person is traveling with, more fellow passengers like siblings or parents or spouses, okay. So if the person is traveling with more people, okay, that means the person is likely to have less age. Less age people we are traveling with more people. Okay, higher age, okay, bigger age people were basically traveling with less people, less siblings or less parents or less spouses and so on. Okay. So this is class how we read the heat map. It is very important in data analysis, in data science, in machine learning. All three of them. It is one of the like very important. Okay, all the graphs that we are going to study today. Okay, all of them are very much important. Okay, now let's continue class. Okay, now class next is your distribution plot. Distribution plot. Okay, now what is distribution plot? What is distribution plot? Okay, basically this okay, the distribution plot helps us to analyze single column of continuous data. Single column of continuous data. So we will pass some continuous data here, class. It is talking about continuous data. Na? Suppose we will say see SNS dot list plot. Okay, here we have to pass the data. So which column should we take? Let's check the fair column. It is basically continuous only. Okay, rest are age and fair column, both of them are continuous. Rest, all of them that you can see on the screen are not continuous. There are other discrete values. They're scattered. Okay. So here in distribution plot, we try to give continuous data. Okay. So we'll take the age column maybe. Okay, age column. If I run this code here, you can see plus two arguments must be missing. I could not convert string to float. We could not convert string to float, so we have to, okay, I'll explain what bins is in a while. Fair, no, acha, sorry. I have to mention complete if here. Then here you can see class. It is basically. Let me show with the age. You will understand better. This is the age data. So where we can see that okay from the it is giving us the frequency distribution. So here you can see that okay within the range of 0 to 10, okay, around 60 people were there. Okay, in the range of 10 to 20, around 120 people were there. Okay, with the range of 20 to 30, okay, more than 250 people were there. Okay, in the age range of 30 to 40. And similarly, class, we can find out about each and every one of them. Okay, so that is your distribution plot. So first you plot first in the first argument you have to mention that okay, which plot you want to plot. Then in the second argument, okay, how do you want to save it if you want to? Okay, so here you can see bins equal to 8. So here, if I want to divide the whole data set, see, age is basically in the age range of 0 to 80. Approximately, the age range is in the age range of the passengers. All the passengers, it is in the range of 0 to 80. 0 to 80 only. Now, suppose class, if you're simply doing, see, if you're simply taking the whole 80 as in single go, so it will give you the age, approximate age, right? Similarly, for if you make two age groups, again it will give you age groups. Here, what we did class when we write bins equal to 8, so what it will do, it will divide the whole age range from 0 to 8, 18, 0 to 80 into 8 equal parts. It is dividing the whole range into 8 equal parts. So here you can see bins equal to 8 means 80 by 8, that means 10. That means 10. So you can see first range is given taken from 0 to 10, then 10 20, then 20 30, 30 40, 40 50, 50 60, 60 70, 70 80. So total 8 are there. Okay, first thing. Second thing here is class your KDE. KDE means kernel density estimation. KDE means kernel density estimation. Okay, so suppose class here right now KDE is false. Okay, KDE is false. Okay. What is KDE class? What is KDE? It is simply your KDE is used to estimate the probability density function of random variable. If you remember that this we have already studied in like 11th 12th class in school only. Okay, your probability density function of a random variable that we write now P of x is equal to, okay, where x is a random variable. It can be anything. Okay, in our case it is going to be your numerical columns. It is going to be your frequency distribution. Okay, so when you give KD equal to true, then it will take the frequency distribution. Right now it is giving you the frequency only, but then it will start taking frequency distribution. Okay. See the difference between the two. Here we are getting frequency for each age range from 0 to 10. This is the age range. We are getting a perfect age range, even though obviously not all of them, okay, not all of them are having the same age. Suppose I say here age range of 20 to 30. Okay, that just means that 10% of the people, that means 10% of the people in the party, okay, like whatever it is, okay, 10% of the people, okay, are not part of your particular age range. Let me explain this again, class. Here you can see we are getting a frequency from 0 to 10, this many people, from 10 to 20, this many people. Okay, that is what happening in KD equal to false. When we write KD equal to true, so we get a density estimation. See, probability density function of random variable. We're getting a density estimation. So here it is saying that, okay, in the age range of 0 to 10, okay, this many people, this is a density. This is the density of people, okay, in the age range of this, okay, 0 to 10. Okay, similarly, age range of 20 to 30. Okay, for all of them, you can see there is an age range given. And then there is a line also that you can see. There is a curve. Okay, so that particular curve is showing us the probability density function of a random variable. That is the exact your KD kernel density estimation it is giving us. Okay, and it is drawn using your estimation. Based on the data, your C1 will automatically handle the estimation in the backend, okay, through some basic algorithms, okay, and then it will be applied to give this curve to us. Okay, let's continue class now. Next is your count plot. Count plot. Now what is that class? Count plot is basically used to analyze single column of categorical data, right class? Okay, so wherever there is incorrect amount of data that is being sold or whatever used, okay, so at that time categorical data, whatever amount, suppose we have your P class, that is your categorical data, your embarked, again categorical information, your sex column, again categorical column. Okay, so you can see there is a lot of categorical data present here. Okay, and count plot will give what? It will give us the frequency of the data values. So basically your count plot is actually, it works like your bar plot only, where it will give you the frequency values of multiple data points. Let's create class simple count plot. We'll write here count plot of age is a continuous column. So we'll take some other column, maybe let's say P class column. Now here you can see in the P class column, you're getting a count plot here. So it is showing us that how many people are there in each and every class. It is giving us the frequency of each and every class. So you can see in the first class this many people are there on the ship. Okay, in the second class this many people, and in the third class there are approximately 500 people. So give me a minute, class. Okay, so let's continue class. Okay, this is your simple count plot. Now in the count plot, now there is one more thing that you can mention. This is simple count plot. Now let's say you want to calculate it, okay, on the basis of sex. You want to see that, okay, from like how many how many males are there in first class, okay, how many females are there. So you can mention here additional argument called as u is equal to t of, okay, so in this case class, you can see it is basically giving us on the basis of sex column, right? Okay, this many males are there in the first class. See, earlier it was telling us that, okay, total around 210 people approximately are there in the first class. Now it is telling us that, okay, around 1 120 people are there. Okay, 120 people, 120 males are there. Okay, and 90, approximately 90 females are there. Okay, so it is telling us that data. Here we can mention one more thing that we can mention here is plus dodge argument. Dodge is equal to true. You can see they're getting printed side by side. Okay, but if I write dodge equal to false, now you can see that they are getting stacked above one another. That is right. Okay, that is also you can mention. Okay, by default it is true only. One more thing that you can take into consideration here is your color. If you write here color is equal to, let's say, blue, green. Color नहीं हो, sorry, इसमें palette हो. Color palette. So you can see it is in blue and green. Blue, green. You mentioned red also. Red it won't take because only two colors are possible. No? Two things are there. Okay, that is why taking blue and green only. You can mention blue and red like this. Blue and red. So that is your count plot class. Now let's continue. Next is class. Next is your scatter plot. Next is your scatter plot. Now, how do we make the scatter plot class? For that, I will be using a plot called as joint plot. Joint plot, and here I will mention x is equal to. See, joint plot. What is that? Joint plot basically helps us to analyze two columns of continuous data. Okay, two columns of continuous data. That is your joint plot. This plus this plot helps us to analyze two columns of continuous data. Two columns we need. So I will write here on the x-axis. Let's suppose I want, let's say I'm comparing age and fair. How the fair is changing with respect to age. Okay, so I will write here age y is equal to fair. So if I simply run this code, here you can see it is creating a joint plot. What is joint plot class? It shows the comparison between two columns along with their distribution plot. So joint plot is basically, it is a combination of two plots. Okay, now those two plots can be, see, the first plot is going to be distribution plot always. Distribution plot is fixed. Inside a joint plot, your distribution plot is fixed. Okay, but the other plot is basically variable. Here you can see inside the box here, inside the plot here, you can see it is a scatter plot. It is a scatter plot. Okay, and outside the box, this bar graph that you can see, this is called as your distribution plot. So your joint plot is basically, it is a combination of distribution plot plus scatter plot. Now instead of scatter plot, I can put something else also if I want. I can put something else also. Before that, I will show one thing. I can put hue here also if I want. I can mention here T. You can see now it is basically scattering them on the basis of male and female. On the basis of their sex, it is scattering them. Okay. Now class, let's continue. I was saying that okay, inside is your scatter plot, but we can have something else also if we want to. How? We can mention here kind is equal to, let's say, hex. We can see now the inside plot is hex plot, hexagonal plot basically. It is creating hexagons. Okay, hexagon is there, or you can take hist also. Hist means histogram. You can see it is giving us histogram inside. So the benefit of histogram or hexagonal plot is basically they can tell us that how much they can also tell us that how much relation is how much the data is concentrated in a particular area. You can see higher the shade. There is a higher shade at fair equal to, you can say somewhere around I think somewhere around 10. Fair equal to 10. Okay, and in the age range of 15 to 35, you can see there's a dark color. That means that more people, okay, paid this much amount of money in this age group. Okay, that is the joint plot. Histogram I have shown you. Okay, we can take hex plot also if you want to. Separate kind equal to hex. See, remember, outside it is going to be distribution plot always. Inside one is going to differ. Kind equal to hex. In this case, it is the inside is basically kind equal to scatter. By default, value of the kind argument is scatter. How you can check that? You can check simply that using plus. Here you can mention this code. The SNS.don't write question mark and run the cell. Here you can see kind equal to scatter by default. There can be other values also kind argument. Scatter, KD, histogram, hexagram, okay, regression, recid. Okay, KD I can show KD, your scatter, hist, hex, reg. These are all used. Okay, so suppose if I write here kind equal to reg. Here you can see it is showing us the regression also. Now, what is the meaning of regression? Here you can see it is showing us a number line. Apart from scatter plot, it is also showing us a number line. Okay, so basically number line shows the how the data is basically increasing or decreasing with respect to each other. That is a regression plot. Okay, then let me show you KD. That is also important. Okay, now here you can see this is your KD plot. Okay, so you can see higher the concentration, higher the concentration of data values, higher the circles present here. See, in between the age of 20 to 30. See, okay, 15 also you can say 15 to 30. Okay, so every time, everywhere it is like just like that one. Here also, everywhere. Okay, that is the distribution. Okay, one more thing that is there is your recid. That also try to see. So here you can see it is giving us a dotted line here. Okay, so in the dotted line it is basically giving us that how many values are lying above, how many values are lying below that particular value. Okay, and that particular value is basically calculated using your the average of the whole fair column. The average of the whole fair column. So guys, that is the joint plot. Let's continue now. Next is your bar plot class. Next is bar plot. So simply see, remember in count plot, count in the count plot, we were basically taking single column of categorical data, single column of categorical data in the count plot. Okay, but in the bar plot class, you can take two columns into consideration, and those two columns, one of them can be continuous, one of them can be categorical in a bar plot. This plot helps us to analyze two columns, one categorical, one continuous. How it works? We'll write here SNS dot bar plot and the data. Suppose I'm writing x is equal to, see on the x-axis we generally take the categorical data. So T, I will take maybe let's say P class for now. Let's say continuous data, fair column. So here you can see it is plotting fair column according to P class. So you can see the first class people paid the highest fare. Okay, then the second class and then the lowest is your third class. Okay, here you can take hue also. Okay, first thing. Second thing class, here you can see here it is showing a black colored lines on the top of the graph. Okay, on the top of the bars in the graph, it is giving us black lines. So what are these black colored lines? Class, these black colored lines basically give us the error in the data. How much error? It is estimating. Okay, there is this much error in the fair column. Okay, with respect to P class. Okay, how much confidence do we have on the data set? You can take hue also. Hue is actually, let's take the embarked column for now. Embarked column is not there. Just T भी तो I have to mention. T embarked. You can see now it is basically giving us data on the basis of the embarked as C and Q. Okay. Now, class, if you remember that. Okay, yeah, that is all for today, class. That is all for today. Okay, it is already post 7:30, so we can stop it here and we will continue from this topic. Okay, everyone.